welcome to Desk of Ladyada.
Hey everybody, and welcome to another Desk of Ladyada. It's Sunday night here at Ladyada o'clock, and it's me, Ladyada. With me, Mr. Ladyada on camera control. He's the voice of reason you hear in the background. And we're just checking in. What have I been up to this fine week? Doing engineering and a lot of purchasing, actually.
That's right.
So I don't know. You want to have any news or updates, or should we just kick it right into?
Let's just jump right in. It was Arduino Day on Saturday. We have a few things to talk and show about that.
Oh yeah, let's show off the Arduino stuff first.
And just a heads up, if you are someone who's in electronics, it's all about how to find things online soon because there's a global part shortage. So the Great Search is going to be something really special to look at every single week. So we're going to be talking about that and more. So let's jump right to the overhead.
Let's go overhead and let's look at some of the Arduino stuff. So like I mentioned, it's Arduino Day. Check out the Arduino YouTube channel to see some of the videos that they, obviously it's always been remote. They've always done videos and then people have local events. But they videoed a lot of the presentations. They talked about like IoT stuff, their learning system, new products, and more. So check it out. It's on their stream. We watched a little bit of it. And one of the things that they did talk about is how they're going to be doing a RP2040 board. They have like the Nano IoT 2040 or something. I don't remember the exact name of it. And it's going to have a RP2040 from Raspberry Pi plus an ESP32 in like their handy little format, being compatible with existing boards. And that was kind of cool. But we also saw, I think it was like on Twitter, we saw it on Tom's Hardware, that there's also a kind of like a DIY Arduino core for the RP2040. So we want to try that out. So this is our Feather, which is the one in the shop, the Feather RP2040. And it's plugged into our TFT feathering. It's color, but I'm keeping it monochromatic. And I have it plugged into a STEMMA QT TMP117, which I can hold in my hand and make the temperature go up. So what's interesting about this is an Arduino. This isn't in CircuitPython, so or Pico SDK. So this is kind of neat. If you want to use our libraries, our code, testing TFTs and sensors is a really good way to kind of make sure that I2C and SPI are working as expected. It's it's not a full, complete everything implementation of the Arduino core, but it's pretty good. This person, Earl Philhoward, did an excellent job. We even opened up an issue and it was resolved in a day. We just said, oh, hey, by the way, to do 0 byte writes, you got to do this bit bang thing. And they're like, oh, yeah, okay. And they did it. And then all of our sensors now work because we use 0 byte writes to detect when a sensor is plugged in. So this is the Feather RP2040, and then we also made a little demo with the there you go, with the OLED display. So it's just showing two I2C devices, and this is on the RP2040 QTify, right? So that isn't out yet. But we wanted to just try it out. Only thing you have to watch for is, the board definitions aren't quite set yet. So this thinks it's a Pico. So like you have to use the GPIO pin numbering, not like, the smart pin numbering that we put on our boards to match other feathers. I think this is going to be a next step. We'll, eventually they'll add, board packages, and then part of that will be pin renaming. So, I think we'll still probably end up using the official Arduino RP2040 package, but it's really cool that there's one while we wait. So maybe if you go to my computer real fast, I can show people where to find this. So this fellow, it's under Arduino Pico. So check out this repo here to download. Again, it's early. This isn't like a good, my very first Pico project, never done microcontrollers before. It's great if you've already done a couple Arduino board support packages and you're kind of like cool with the process and you're cool with debugging and being okay with that in-progress board support package. So that was kind of neat. I thought that was nice. Okay. Next up, we have been doing more keyboard stuff. So our NeoKey breakouts made it into the store. So you want to go back to the overhead? And I'll show this. So this is, it's a demo that we had for the product that we put into the shop. So when I press the button, it reads the button press and stops sending NeoPixel data to that NeoPixel. The cool thing is, we fixed the reversed. Oh my God, that's so bright. We fixed the reverse NeoPixel, so now it's glowing up into the keys, which is the one thing that we didn't have quite right the first time we made these. But so far so good, and we got the socket working pretty well, and we're trying out different keycaps and stuff. So this is just the simple breakout, and then we're also working on that 4-key modular breakout using a seesaw chip that does the I2C. So this one, it does not have the correct direction NeoPixels, but it does have the switch to NeoPixel detection. So over I2C, reading the switches and then writing the NeoPixels. So this will be chainable. You'll be able to connect multiple ones together. But just trying this out, and I let this sit on my desk, and then every once in a while I press a lot of keys very quickly to make sure that the I2C isn't hanging or being flaky. But so far so good. I've been using the SAMD09 for the seesaw, and one of the things I was thinking of is, because of this part shortage, if I can't get this chip, what's an alternative? So I looked at, what is the cheapest microcontrollers on DigiKey, and it was like the MS51 series for basically something that's, about 1K of RAM, about 16K of flash. And the MS51 from Nuvoton, which is also a chip that Pomerone uses for their little I2C breakouts. And I looked into it, and it was interesting. It's like, this is a very, very inexpensive, like a 20-cent microcontroller. Not sure if it's worth it to move from something that's, 50, 60 cents down to something that's 20 cents for the complexity that comes with it. I rather like the SAMD series. But I have to be, flexible, willing to move at a moment's notice to a different chipset. So I ordered a little dev kit for the Nuvoton MS51. I'll try it out. I think, it's annoying because there's not a great, there's not AVR GCC support. You have to use SDCC, different compiler, and so a lot of things that it's not like you can just run Arduino on it. All the code has to be written basically from scratch and in very low level C, and I don't even know what support really there exists for SDCC. But I don't want to use Keel or Air or IR, whatever it is that's available. I want to try stick to a free compiler. So maybe in a future Desk of Ladyada, I'll do a Blink demo for the MS51. So that's me starting to think about what chips are available. We just did a bunch of purchasing to get chips that we needed for the next 6 months because the lead times are starting to become, 50 weeks or so. Speaking of chips, I also got the chips for this Metro, which is slowly but surely coming to life. This has been delayed, but we're actually getting pretty close to launching it. I've designed the tester, but the board itself is pretty much qualified, ready to go. And I wrote a demo that I just wanted to test out Shield compatibility. So I made a little demo that just bounces some DVD logos. So you can see this is running CircuitPython, and it just has a little bit of like a graphics demo. I'm trying to test, it's a 500 megahertz processor. What does that mean? You're not going to get 4 times faster than a SAMD51 because this has your flash memories off chip, so it's much slower to get to, and there's just tightly coupled RAM. But it's still it's maybe two times faster, and not a ton of RAM, but still a reasonable amount. So you get 64K, so you can do graphics and IoT stuff with it. So this was just me just trying out some graphics projects, making sure that shields work because it's Shield compatible. I'll make sure our shields still work.
Okay, some questions. What about this is on other chips to try. What about the Tiny 406 or similar? What do you think about that?
Nothing is as cheap as Nuvoton's. They're just half the price. For you do need to have a significant amount of RAM and flash to do I2C and manage a protocol. I don't want to write an assembler, so I need something that has at least 8, 16, 32K of flash, and I want to drive NeoPixels. I'm going to need to have at least a K of RAM for the stack and my NeoPixel buffer. It's just tough to, I know that there's chips that are 10 cents and it's you get 56 bytes of RAM. I need more than 56 bytes of RAM.
Okay. And just to confirm, you ordered a 8051 micro as a backup in case we can't get SAMDs. Yeah.
You know, I'm always
Adapter die, everybody. Adapter die.
Just for this one case.
Here's the thing. Like, we've had to deal with COVID for the last year, and we had to change what we were manufacturing for a while, in addition to the things that we normally make.
Well,
like, you gotta roll. There's natural disasters after 2008, the recession. You just have to be ready now. Like,
yeah,
that's pretty much it.
I'm not like going to do it, but I was like, well, this is a good, it's a $20 dev board. Like, I'm not going to spend a ton of time on it. I'm not going to buy a $6,000 compiler yet. But it is something that, I'm like, okay, let me get it and just have it in case this is something I need to look into. Again, I might not be able to buy new Atoms, it's like, but I want...
Tiny 406, I guess, has I2C and Arduino support via Tiny Mega Core.
I mean, I wouldn't be able to use Arduino. Like, there's just, I would have to do it in straight C. I've learned that you can't, even for the SAM-D09, you can't use the Arduino core. That, there's Arduino cores for it. You can't. You have to write it in plain GCC if you want to have something that is an I2C peripheral that just does an I2C peripheral and it doesn't have overhead. It's just, you don't have enough memory to handle the overhead of Arduino, which is a very handy overhead for this particular case. You have to get rid of it and go straight to direct control of the registers because you want to run the whole thing quite tightly.
Okay, what else you got going on?
Okay, I got some this cool. Let's see. I've got this cool sensor chip from Sensirion. It's the SCD41. So this is, I got these actually a couple days ago, but finally opened up. So this is a CO2 sensor in like a little surface mount package, which is kind of neat. These are not cheap, but I got some samples, and I designed a STEMMA QT board for it. I could show that pretty fast. Let's see, breakout boards. Okay, let's, you can pop up my computer. So, this little sensor module goes in the center, and it's kind of cool. The green doesn't show up.
Yeah,
it's funny.
Again, green screening it out.
Yeah, we got it. I don't know. It's fine. I don't know. It's cool. It's interesting though because it's not the insert. It's weird.
Yeah.
Oh, there you go. All right, cool. So this is the sensor in the middle. And even though it runs from 3 to 5 volts, I thought of putting a regulator on there and a level shifter, more for like pin protection. I mean, it's like it's quite an expensive sensor. So I was like, I'd really hate for somebody to just like plug in power into ground and vice versa and fry the chip. So having a ruggeder, like at least an input protected regulator could prevent some common things. I don't know how delicate this sensor is, but like, if the breakout's $50, I don't want somebody to be like, I just like smashed my CO2 sensor by accident. So we made a quick breakout for this, and so I'll send this out and I'll try it. I mean, what's neat is Sensirion has drivers in Python and Arduino, so it'll be a very easy sensor to use. They've already written the code for microcontrollers, which is like really nice. Haven't seen that from a lot of companies before that they've added. They've written the Arduino and Python and Raspberry Pi code for you, so that'll be cool. I mean, it's just so tiny. I think this will be very common. I think a lot of industries are going to use these for like home air quality monitors. It's just very tiny compared to the SCD30, which is great. Let's see. What else did I have on my list? Do you remember? I don't know.
Other things?
Yeah. Let's see.
The Arduino Day stuff. You got STEMMA QT designs.
Oh, we got the Trinkey. I'll show the slider Trinkey that you came up with.
Yeah, I don't know if we're gonna do it, but.
No, I don't either. But I was just like, well, it's a Trinkey. So, in addition to all the other Trinkeys, it's like Trinkey Tuesday. I don't know. We have to come up with a Trinkey of the day. So you thought like, oh, why don't you make a Trinkey with a little slide potentiometer?
Yeah.
Only thing is that I'm concerned that you'll slide it and you'll yank it out of the USB port.
Sure.
But
Someone might.
maybe, but you don't know until you actually try it out. So I thought we would get one as like a mini slide potentiometer. It's like an inch and a half.
I think you could put a rubber foot underneath it and it would just sit on your desk and be fine.
Yeah, maybe.
You could also put the little extender cable and just put it anywhere you want on, like, your desk or something.
Yeah, I don't know. Yeah. It's interesting. So slider. Well, this actually should say slidey Trinkey. Slidey Trinkey.
What's the difference between that CO2 sensor and the other ones? Speed
Smaller. It's just really small. It's pick and placeable. You can fit it into a small space. Okay.
What's going on?
So let's see. Okay, got the RP2040, NeoKey. The only thing left was doing some more STEMMA QTification of old designs. So you'll notice like every week or two we come up with a new, a sensor that we've already made. We will revise it to add STEMMA QT connectors. Usually we have to change the shape and not the schematic, but the mechanical outline. Some people are a little annoyed by it, but I have to make the change, and I might as well just make it and be done with it, because I'm not going to have to make the change again. Basically, having all of our sensors be in a standardized size, standardized pin order, is worth it. So this week, I'm doing the 7-segment backpacks, which are pretty popular, a very old design. They have an HT16K33 on the back, and then a 7-segment or alphanumeric segment LED matrix on top. And then we always had the I2C plug-in on the top. I'm going to keep that actually because there's so many designs that use it that I'll keep that pin order and that plug. And then on the side here, I added STEMMA QT connectors that stick out. So you'll be able to chain these together to make long 7-segment displays. So that'll be, it'll be an upgrade. We'll replace the ones we have with these, and I think we'll be able to keep the price the same because we're just adding these 2 little connectors. Otherwise, the code's going to be identical. So that'll be nice. So, slowly but surely going through all the back catalog and QTifying. I think we've done 50 boards probably so far. We've got 50 total. A lot of, all new ones, of course, are STEMMA QT, but then going back and redoing the old ones has been, it's tough because it's like I don't want to discontinue some, but some it's like, wow, we really don't make a lot of these. Or, they're getting close to being discontinued. I have seen more things get discontinued lately. I mean, maybe I'm just getting to that 10-year, like I've been using this part for 10 years. At the end of 10 years, support is being dropped. Speaking of which, for the great search, which we'll jump into next, there are these really long lead times now for components. We did a lot of purchasing this week to make sure that we had some of those long lead time components. We started ordering and booking them out. So, they're not in stock, but we could at least book the order with factories and let them know, hey, this is when we're expecting to get more. So if you do get stock, it's not like nobody's going to have nothing for a year. We just don't know what and who is going to have something within the next, 6, 9 months, 12 months. So, booking things out, hopefully we'll be able to keep the majority of our products being manufactured. Definitely a tough time if you need a Wi-Fi or cellular module. I saw Particle has 56-week lead time for their cellular LTE modules, or the boards that use the cellular LTE modules. Even I think the NRF52840 modules that they were using have 20, 30-week lead time. So it's a lot of weeks. But this happens every time there's a recession. On the bounce back, there's always this component crunch, and then 6, 9, 12 months later, it dissipates. So we'll eventually have components again. It's not like there's no sand in the world. There's lots of sand. We'll turn those into semiconductors and sell them. And there's a lot of money to be made. So I'm not worried about that. Just in the short term, it might be tough to get some parts. So just always be on the lookout for alternatives and replacements. And I'd say don't be afraid to redesign a board if you can get a part. PCBs are annoying to respin, but PCBs are usually not the most expensive component of your design, and they're always available to be made. So you could respin the boards, get new boards, and keep the old boards. So when you do get that older component back, you could swap it in and have it be like a drop-in replacement, basically. So you don't have to even throw anything away. You're just kind of delaying that build for a few months. So the component that we had to find this week, we use a lot of what?
I have to start the intro for the Great Search.
Oh yeah, why don't you start now?
Ready?
Yeah.
Where in the world is that part I need? The Great Search with DigiKey.
All right, the Great Search brought to you by DigiKey. Thanks, DigiKey and Ladyada. Ladyada is going to use her powers of engineering and procuring parts for 15 plus years, and using DigiKey site to show you how to find what you're looking for.
Yes.
What are you going to look for this week?
Okay, so as we were mentioning, due to this post-recession boom in components, a lot of components that were hard to find are now impossible to find. Some that were easy to find are now impossible to find. It's just everything is very long lead time. A lot of parts are evaporating, as I like to say. They're being gobbled up. So one of the components that we've used a lot of and had even though it's not recommended for new designs and R&D, we were able to get large quantities, no problem. The lead time was a little long, but you could still get tons of them. And then this week they just completely disappeared because I think this part was used by other people. They really needed it, and so they purchased it up. So this was the part that I like to use. This is the APX 803 26 SAG. So the APX 803 part, this is a simple reset supervisor. So what it does is when you plug in power, and this is people who do electronics, once you get past just using modules together, you'll quickly hit this. If you power up some circuitry, and each one it turns on at different times, based on when the voltage rises past the turn on voltage for that component. You can get components that the microcontroller has started up, but the display hasn't, or the display has and the microcontroller hasn't, and it needs to be usually this is why you have a reset for your sensors or displays or peripherals, where you actually pull the reset pin low on after the microcontroller or microprocessor has booted, to really make sure everything is reset and comes up together at the same time with fully clean reset values. But for us, because we're using a lot of modules that beginners are using, they sometimes don't connect the reset pin, or they don't want to connect the reset pin, or they forget to toggle it, or whatever. And so we'll add auto reset circuitry, and what that will do is make sure that when it's plugged in, the component itself will not power up until won't come out of reset until power has reached a certain level. So it just means you get a much better experience. You're less likely to have flaky, confusing responses with your peripherals. So let's go to the overhead real fast, and I can actually show a component in question. So this is a display module. So this is a TFT display breakout. And I have level shifting. Here is that APX 803. So what this does is that when you power this TFT, it'll perform a hard reset and hold the reset low until the power gets up to about 2.7 volts, and then it'll hold the reset for a little bit longer and then release it, just making sure that the TFT really comes up very cleanly. Otherwise you can get again, flaky behavior. You think it's responding, it's not really. Has old values from, when it was previously powered on, or they're corrupted a little bit. And if there's a reset pin, but if you don't actually perform the hard reset, this chip will do that favor for you. So they're lovely little chips, and they're pennies, right? They're not very expensive. I love to sprinkle them on displays, especially. I found that they've give a much better experience to users. So back to the computer. So the APX 803, like I said, I was able to get it. Now I can't. And also the lead time is 43 weeks, right? I mean, I don't even know what's going to be going on in 43 weeks. That's
Move to Mars by then.
I know, it's ridiculous. But what's cool is you can see like they're inexpensive. You know, for 10 cents or so, you can have one of these auto reset supervisors. I just really love them. So let's find an alternative. Now this was again, this is not for new designs, but I was able to get this, no problem. This part, I've been using this for years, and there's been always plenty. And then, you know, recession ended or post-pandemic ended, and these were all swept up. And I was like, you know what? Now's a good time to find a replacement. So I'm going to use the product attributes here to find a good alternative. So I don't care who the manufacturer is, so I'm not going to click that. I don't really care about the packaging yet. I'll deal with that later. Obviously, I don't want it to be not for new designs. I want active. I do want it to be the same sort of thing, a simple reset, power on reset. I want it to be open drain or open collector. What that means is, yes, you know, it can reset the microcontroller. Actually, it's interesting. The IMX RT board. I also have the IMX RT1011 microcontroller board I'm designing. This microcontroller in the data sheet, like the app note for like minimal schematic, it also recommends to have an auto reset circuit. So it's the same chip used here. Again, I really like this chip. Using a lot of designs of mine. So I want open collector because that way I can also have a reset button. Or if I do want to have a reset control, I'm not going to have like two, you know, signals fighting each other. It's like this will hold it low, but then if I have a reset button that pushes the reset pin low, that's also okay. So let's do open collector. Active low, that means when I want to be in reset, I keep it low. So for this chip, the reset timeout is 140 milliseconds, and the voltage threshold is 2.63 volts. I'm not going to click those because, again, I don't care if it's 130 millisecond, 140, 150. The voltage, I don't care if it's 2.5 or 2.7. I just need it to be around that number, right? So I don't want to be too picky. I don't pick those. I do want to have the same package, SOC 23.3. I really would like it to be drop-in replacement. And I only want to monitor one voltage. Okay, so let's look at what's available. So here, you know, I'm in the normal search. I'm going to have my classic, only search for active, and only normal stocking. Why not, you know, in stock? Because there's a lot of stuff that isn't in stock right now that, like, might be soon. Again, stock numbers are, like, so confusing and weird right now. That I have some APX 803 in stock. I'm good for, like, a month or two. But if that lead time is 43 weeks, I will run out before my back order gets fulfilled. So I just want something that is likely to come into stock in the next few weeks or few months. Okay. So the reset timeout, again, the one that I had was 140. You know, I think anything between, you know, 120 to 150 is fine. It doesn't, for my purposes, it doesn't really matter as long as it's held down for about 100 milliseconds. Maybe I'll pick even 100 milliseconds. Okay, so that's good. Then the voltage threshold. So remember, the one I had was 2.63, and the reason I don't want to be picky is you can see there's 2.625, there's 2.63, there's 2.64, 2.7. All these are like pretty much okay. So I'm going to pick like 2.625 up to like 2.9, because everything I'm using is like basically 3.3 volts, and so as it rises, I want this to turn on a little bit before the 3.3 volts, and also, you know, if the voltage is a little bit low, I don't want it to kick in by accident. So, you know, maybe something like that. Okay, so let's apply. Okay, great. So we're already starting to see like, ooh, these look good. These are SOC 23s looking nice. I can start scrolling here. So what's nice is, you know, a lot of these, there's stock. These, you know, there's a couple thousand stock. This one has 33,000. So you know, I am a little price sensitive. I sprinkle these on board, so I want something inexpensive. So I'm going to view the prices at about a reel, and a reel of parts is 5,000. So I'm going to do that, and then sort by price, and I'm going to see these TI parts, the TLV 803 EA 26s. So those came up. I'm already feeling really good about this. Why? Because my part was the APX 803, and this is the TLV 803. I always love it when the part I'm looking for has the same like number in it, because that gives me a hint that like they're designed to be cross-compatible. Just one uses the TI prefix TLV, and the other one uses the diodes prefix APX. So the next thing you have to watch for is, like many chips, especially the low-cost ones, they often come in multiple package formats that have the same part number, which is like so tricky. And this is one of the part. Luckily, I remember this from when I first spec'd the APX 803. So let me look up. I have the data sheet for the APX 803. So you pull it up. See, now recommended for new designs. Okay. They actually recommend using the 803S, which is also out of stock. Or maybe it's the, I'm trying to remember, maybe it was a BGA part. I don't remember. So there are two packages here. There's this part, and they're both SOT23. One is the SA package, which has ground reset VCC, and then the SR package, which has reset ground VCC. Why would you do such a thing? I mean, it's probably like this was replacement for something else. Maybe they had a customer who was like, I really need to have this particular pinout. There's some reason, but basically you have to watch out, because if you get the wrong one, you're going to be like very unhappy. This chip is not going to do what you think it's going to do. I don't even know what it would do. You just get very confused. So it'll be trying to pull ground down or like reset up. Who knows? But the one that we are replacing is the SA package, right? So it's SOT23 SAG, which means we want ground reset VCC. Okay, cool. So now when we go back here, we want to look at the data sheet for the TLV 803, which I already downloaded. And you'll note that they also have various packages. They have various types. This is the topology. This is, what it does. Is it push, pull, open, drain, active, high. So, yes, we want the 803. We got that. There's multiple voltages. Cool. We got the one we wanted. And then, there's different packages with which one is reset. So let's scroll down and see if we can find the okay, they have like 8 packages. Too many packages. So for this one, we want the one that matches this. So ground reset VCC, ground reset VDD. And we want not the SC70, but the SOT23. So this one, ground reset. Oh, and there's like a third one. Wow. They went the other way too. They're like, we'll flip it around anyway. I don't know. Maybe it's, again, a replacement for some other part that has a differing pinout. So we want the DBZ package, the Dragon Ball Z package. Cool. And this is the R pinout. So you want the non-R. And so if you look here, it's a little, maybe I'll zoom in. You can see this is the R. It has the R in that part number, and this one doesn't. This is the one we want. Yes, TLV EA26 Dragon Ball Z. Not R. Confusing because this has R in the part number, but that's for tape and reel. I'm pretty sure this is the right one. But I'm still going to get samples anyways to try, because I think this is very... Oh, wait, sorry, I clicked the wrong thing. I meant... Hold on. See, I was confused. 1 second. I'm going to find... I want the TLV... Yeah, sorry, it's the 26R DBZR, and this is the 26DBZR. This is correct because there's an R but an N, but not after the 26. So I did get it correct. Very tricky. Watch out. I have been fooled multiple times by multi-package parts with different pins. In fact, even today, looking at the resistive touch controller, I was looking at the pinouts for the QFN and the TSOP part were different. I really wish everybody would just sort of stick to one pinout, but they just don't. So I'm still going to get some samples of this. Make sure that it's the right one, because I'm paranoid. But now at least I have a drop-in alternative for that APX 803. So good news is I will be able to keep manufacturing all the parts that use the APX 803 just by dropping in this component after I test it and verify that it's a drop-in replacement. Yay! We'll be doing this for the next 6 to 9 months.
And that's the great search for this week.
Where in the world is that part I need? The great search with DigiKey.
Sneaky R.
All right.
Okay.
And that's Jessica Ladyada for this week.
Yeah. Any final questions? We're gonna wrap
No.
up. All right. Thanks,
for
everybody.
Enjoying the search. So we'll see everybody during the week. We have our shows Tuesday, JP's product pick. Wednesday, 3D Hangouts with Noah and Pedro. Show and tell, Ask an Engineer. We've got JP's workshop, and we also have Scott's deep dive. And we have a Collins lab notes every single day, Monday, Tuesday, Wednesday, Thursday, Friday. And we have a bunch of other stuff in store, so stay tuned to the Adafruit sites, channels, social media, and more.
All right. Thanks, everybody.
Bye,
Thanks for
everybody.
tuning in.